Hello learners, I welcome you all to Dr. D.Y. Patil Vidyapeeth, Pune. Okay, in the last session of our programming, we had already discussed that what are matrices, what are vectors, how to implement these concepts in R, then how to execute matrices using matplot function. Okay, last time there was a little bit confusion, and even I got messages from the student to just rediscuss the same, that is plotting the matrices or data frames. Okay, so let me share you my screen. Okay, so here is the same last code, as you all can see. Is the screen is visible to everyone or not? Yes. Is the screen is visible? Okay. Thank you. So, in the last session of our programming, okay, let me tell you, your course code is OMBAIML 306, or it is OMBBA 306. Okay. And the name of your course is R Programming for Data Preprocessing and Visualization. Okay. So in the last session of R Programming, we had discussed what are matrices, what are data frames, how to slice matrices, data frames, how to create data frames, how to perform different functions or operations on matrices and data frames. Okay. So in the last session, there was a little bit confusion to the students that how to plot matrix using matplot function. Okay, so today we are just going to rediscuss about the same thing. Okay, as you can see, just look on the screen of our studio. Here M3 is the name of my matrix. Okay, by executing it you will get the matrix. Okay, fine. Now, as we know that matrix is a two-dimensional data structure. Two-dimensional means it will arrange the data in rows and columns. Okay. Now, to plot a matrix using matplot function, we require certain parameters need to be passed to the okay. Now, so here as you can see, matplot function has been used because I want to plot M3 matrix. Okay. So in matplot function, what you need to plot, you are supposed to give that variable name, and M3 is my variable name. If you want to plot the data frame, then you have to mention the data frame name. If you want to plot list or vector, you have to provide the variable name of list or vector. Okay. So whatever you want to plot, the very first parameter will be the value of the variable you want to plot. Clear? Now, next comes type argument. Okay. Type means what? Time specifies that while you are plotting, what you want to be displayed while you are plotting. Okay. Type parameter will take string. Okay. Various values that you can use or you can do experiment with type parameter are L to display plotting in form of line. You can have solid lines. For them you can use parameter, you can pass parameter S. Okay, for type. Okay, next if you want if you want to plot points, then you can pass P. Okay, so let me show you. So this is how the plot looks like, because in type parameter, L has been mentioned. L means line. If I change it, hold on. If I change it to points, okay, that is I want to, rather than viewing the graph as a line, I want in form of points. So if I execute it, see points has been mentioned. Okay, if I want a solid line, then I had written S, as you can see. So this is how you can pass values to the type parameter. Okay. And these values are fixed. Okay. It's not like you can pass any of the alphabet. Clear? There are hardly 8 or 10 parameters you can pass for type while plotting the data structures or any of the variable. Clear? Now the color has been mentioned as blue, and this is why the plot has been displayed in blue color. LWD stands for the width of the line. It is ranging from 0 to 7. Okay. And L is the line type, that is thickness of the line. Clear? So how much thickness you want, based on that, you can plot your matrix M3 variable. Clear? Now, any doubt you can ask regarding this matplot. Okay. This was the part need to be rediscussed because certain students asked me the queries regarding matplot. So this is why I had recontinued with this same concept. Okay. Now, next is in one of our course, that is OMBAIML 301 in basics of AI and ML subject. While we were discussing about measure of dispersion, measure of shape, then measure of central tendency. Okay, so there you guys asked me to show the practical implementation, and that time our studio was not getting open. Okay, so again I'm going to show you. Right now you might not see the measurement of shape, but you will get IQR type of thing. You will get values for quartiles, Q1, Q3, if you remember. Okay, these Q1, Q2, Q3 or quartiles concept is the part of measure of dispersion. Measure of dispersion mentions that how much data points are spread all over the data set. Clear? So here there is a data set named iris. Okay. I want to see the data. See, data iris. Iris is the predefined data set already available or installed in RStudio. Clear? So this is the default available data set, one of the default available data set. To get this data set in my current programming, I want to use a function that is data. Clear? Because I want to import it. Next is, now I want to see that what are the attributes or features iris dataset is having. So for that, head function has been used. Head function will provide you only 5 records about the iris dataset. But using those 5 records, you can have one more additional information, that is what are the attributes or features available in iris dataset. So as you can see in the console screen, we have in iris dataset, we have total 4 attributes: sepal dot length, sepal dot width, petal dot length, and petal dot width. And the last, sorry, we have 5 attributes, and the last one is species. Okay, so total available attributes or features in iris dataset are 5. Clear? Now, as you can see that this sepal length, sepal width, petal width, these all 4 are numeric type of attributes, and species is the string type of attribute. So if you want to see that to what data type they are contributing towards, so you can use class function or you can use type function. Okay, now to get the next instruction is summary iris. Okay, now what is summary? If you remember, there was a discussion between us that about descriptive statistics. Okay, in the descriptive statistics, what we try to do is we explore our data set. We explore what are the variety of values we are having as data points in our data set. Okay, then what is the mean, that is measurement of to perform measurement of central tendency. You have mean, mode, and median. Clear? Next, for calculating the range, you have variance, standard deviation, quartiles, and all. Clear? So if in R there is a function which is used for descriptive initial descriptive statistics. Okay, so that function name is summary. If I execute this summary, what you will get now, have a view of it. Okay, hold on. Okay, now it is visible easily to everyone, I guess. So here in sapple.length, the minimum value you will get for the feature or attribute sapple.length is 4.300. So there are records where sapple length is 4.300. Sapple length's first quartile value, if you remember, quartile is the part of measurement of dispersion. Clear? That is how much spread is there among the data point. So if you remember the box and whisker plot, okay, there we were discussing about Q1 and Q for quartile measurement. What we do is we divide our data set into 4 equal parts. Clear? Out of those 4 equal parts mean 25% value to each quartile. Now, to calculate the mean mode, there is nothing like mean and mode in box and whisker plot. What we do is we figure out the median. We work with median in while plotting or using box and whisker plot. Clear? So for that, we need a first quartile value and third quartile value. Clear? Based on that, we will calculate Q2 and IQR. That is interquartile range. Now to calculate IQR, there was a formula that Q1 minus 1.5 into Q3, and for minimum to identify the minimum value of IQR and to identify the maximum value of IQR, there was a formula. Clear? That is Q1, which was for finding the minimum value, we were subtracting the Q1, and to find the maximum value, we were adding Q3. Clear? So this was the part of IQR, that is interquartile range. And to identify IQR, we are having a little bit exploration about the data. We are having minimum value. We are having maximum value. As you can see, we are having first quartile value for each of the attributes. Okay. Next, we have third quartile value for each of the attribute. Okay. We have median and mean. Okay, that is mean means average of all values. Median is the centralized value. Clear? And mode is the most frequently occurred value, which is not over here. Okay. Now, in species in our data set, there are total 3 species, that is Setosa, versicolor, and virginica. And each of these species are having 50 total number of records. So total number of records for all by including all the 3 species total will be 150. Okay, so to know that how many total records are available in the iris dataset, there is again a new function, that is dim. Dim stands for dimensions of the dataset. Clear? So dim iris, by writing it, you will get the total number of records and total number of columns, or okay, total number of columns will be displayed to you guys. Okay, so here it is dim. As you can see, 150 and 5. 5 are the total number of columns and 150 is the total number of records. Clear? So this was the basic which we had, which was left or need to be rediscussed. Okay. Now today we are going to cover how minimum and maximum value is being calculated. See, there is nothing for calculation of minimum and maximum value. How you can view the minimum and maximum value? You can, if you are having the complete data set, okay, by just viewing it, that which is the lowest value. Even in Excel sheet, you can apply min and max function for that. And to do manually, you have to view each and every record. Clear? For that specific attribute. And after that, you can conclude that, like for example, if I'm having values like 10, 15, 28, and 3, and the last one is 67. Now, which one is the minimum value? By observing all the observations, based on that, you can conclude that which one is the minimal value, okay, and which one is the maximum value. So there is no such calculation. The only calculation is which one is greater, if value 1 is greater than value 2, Okay, then value 2 is smallest and value 1 is greatest. This is how you can calculate. Okay, and every time you have to do it by taking two values at a time. Okay. No, not only 5 columns of the data set. My iris data set is having total 5 number of columns. If I'm having XYZ data set, which is having total 100 attributes or columns, then while using them for that XYZ data set, I will get 100. Clear? Because iris data set is having 5 number of columns, so it is giving me 5. Every time only 5 column of the data set will not be displayed. Based on your data set, total number of available columns in that data set will be displayed, and total number of records available in the data set will be displayed to you guys using them. Clear? My only iris data set is having 5 number of columns. Although in reality, there are not only hundreds of columns, but there are thousands of columns available in a data set, because we are about to train our machine. And more number of columns, more number of records will make your machine learning algorithm most accurate and perfect for prediction. Okay. Now, coming to the new unit, that is, okay. So today we are going to uncover unit number 3 of your course code OMBAIML 306 or OMBBA 306, and your course name is again R Programming for data pre-processing and visualization. Today we are going to cover unit number 3. Let me share you my screen, PPTs. I mean, okay. Okay, so if the screen is visible to everyone? Okay, so your the title of your unit number 3 is Fundamentals of Programming in R. Okay, don't get confused, because some of you are already enrolled for AI ML specialization, and some of the concepts are getting repeated. Clear? So don't get confused. Go with your syllabus. See over there that which unit is comprising of what. Okay, rather than assuming or doing guesses. Okay. So in unit 3, now today we are going to learn about the fundamentals of in programming in R, because we are dealing with R. But universally, or if I talk genuinely, on genuine basis, any of the programming if you take, there are certain fundamental concepts in each and every programming. Not only in R, even if we talk about C, C++, Java, ASP.NET, PHP, any of the language, even Python, whatever language we are using, each language are having common fundamental programming concepts. Okay, so today we are going to learn what are those fundamental concepts. Okay, so, and how to implement those concepts in R. The concepts are available in each and every programming language, but the fact is their implementation is different within each programming language. Clear? Okay, let me check what we students are writing. Okay. See, right now I had not imported the data. Okay, what I have done is my data set, iris data set was implicitly available in RStudio. Okay, so I just call that data set. It's like you are calling a person who is available in your home only. Okay, so it's just like that only. Right now, I had not imported. Okay, I use the word import, but it is not the correct word. I had just called the available predefined data set available in the RStudio. Okay, I will let you know how to import. Hold on, have some patience. I will show you how to import the data. Okay. But to call the implicitly available data set, you have to use data function. Data in parenthesis double quote, you have to write whatever implicit data sets are available. Okay. R is not having only iris implicit data set. It is also having empty cars and so on. Okay. I guess Titanic is also available. No, Titanic is not available. 4, 5 predefined data sets are implicitly available in RStudio. Okay. So have focus on the screen. Today we are going to cover the most important part of our programming. Okay. Now, when we talk about what are the fundamental concepts in any of the programming language or specifically in R, then these 4 concepts comes into the picture. The very first is operator. We are now aware of the operators concept. What are operators? Okay, we have arithmetic operator, relational operator, assignment operator, logical operator, bitwise operator, and so on. Clear? Next comes conditional statements. I'm just giving you a brief on all of these concepts. I will take you there. What are these concepts? See, conditional statements are the statements which require conditions to execute the part of the logic. Okay, like for example, if your petrol tank is empty, only then you have to fill the fuel. This is a condition. Okay. If you are hungry, what you are supposed to do? You will eat. Clear? This is again a condition. Okay. So conditional statements, also known as control structures. And by saying the word control, control means that condition. Clear? Even if you see any of the mischievous type of kid or child around you, you put a condition just to control that mischievous type of kiddo. Okay, so this is again what is that? That is again control. Again, you will put a condition to control the things. Clear? So conditional statements, or you can say control structures, are same. Don't get confused. Clear? Next is loops. Loops means whenever you want to repeat something, okay, multiple times, you have to use the concept of loops. And the last fundamental in R is functions. Functions are what I will let you know at the end of this session, okay, because we are going to discuss each of these one by one. So taking you all to the operators that are available in R. The very first operator is arithmetic operator, which is comprising of plus, addition, subtraction, multiplication, division, and modulus. A plus B, A minus B, multiply by D, A divide by D, and A modulus D, A modulus B. Clear? So these are the available arithmetic operators. Next is assignment operator. Now you guys know how to assign a value to any of the variable. Either you can write A equal to 10 or you can put A arrow 10. Both statements are same. Okay. We had seen it earlier. Okay. Next is logical operator. Logical operators are what? They work on logics and the output they will give you in terms of true or false. Clear? For example, again, okay. Have you ever gone for issuing if you want to issue a driving license for yourself? There are certain conditions for that. The very first condition is your age must be more than or equal to 18. It varies. The value of the age will vary with respect to the nation. Okay, I'm just talking about India. So your age must be greater than equal to 18. Second thing, your nationality must be Indian. Clear? So only then you are eligible for driving license, for Aadhaar card, PAN card, and so on. Clear? So what I'm saying you, logical operators will always give the output in the form of either true or false. Okay, and these logical operators are technical. Generally, we use them with while we are dealing with the conditions. Like right now, I have put forward 2 conditions. If your age is greater than equal to 18, logical AND operator, and your nationality is Indian. Clear? In this case, if both logical and will be implemented like if both the conditions are true, only then true will be given to you. And if any of the condition is false, it will give you false. Clear? I require that condition 1 and condition 2 both must give true. Okay, this is what logical AND operator is. Logical OR operator mentions that out of two condition, if any of the condition is true, any one is true, I will give you true, else I will give you false. Again, we can assume that if both the condition are false, logical OR will give you false as output, else it will give you true. Okay, these are nothing but the phrases I am just using. Clear? Next is logical NOT. Logical NOT will reverse the things. Like if you are getting something true as output, logical NOT will convert it into false. And if as an output you are getting false, logical NOT will convert it into true. Clear? So whatever you provide, based on that, logical AND or NOT will perform. Clear? Next comes relational operator. Relational operators are used for to identify the relation. Relation means if one of your sibling, you are elder to your sibling, okay, to your younger sibling. What does that mean? You are greater and that sibling of yours is smaller. This is what the relation is. So relational operators are used to identify the relations among the variables or data structures. Okay. So greater than, less than, greater than, equal to, less than, equal to, and not equal to. Equal to is also known as comparison operator, where you are trying to find out that whether that variable is having that same matching value or not. For example, if x is equal to 10 and I want to test that whether z is also equal to 10, so how can I do it? So for that, I have to use this double equal to symbol. If z is equal to 10, this means that I'm trying to compare z with 10, that whether z is also having 10 or not. Because if I write single equal to, this means that 10 will be allotted to z. But I want to know that whether z is having value 10 or not. So for that, I have to check. And to check, to compare, I need to use this double equal to. Okay, let me see the chat. Yes, I will show you the practical implementation of these logical operators. Have some patience. In the next slide, you will come to know how to implement these logical operators. Just hold on. I'm going to show you. Okay. Next and last is miscellaneous operator. Okay. Miscellaneous operators are colon and percentage multiplied by percentage symbol. Okay. Now colon, as you all know, colon will give you sequence. Okay. If you remember, if you need to print a sequence of any number, you have to mention the start and end. 11 colon 20. This means you want to print the sequence from 11 to 20 and 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20 all will be displayed to you. And this is how you can use the colon operator. One more miscellaneous operator is available, which is used to multiply two matrices. Okay. So if you want to multiply two matrices, one more provision is available in R programming. You can use modulus multiply by modulus symbol to multiply the matrices. Clear? So this was all about operators. Most of the operators we had already covered with practical implementation. Okay. The only left out one are the logical operators. So here we go with logical operators. Now, second fundamental concept of R, conditional statement. First thing, conditional statement works with conditions only. If there are conditions, only then you are supposed to use them. Okay, and to use them, there are 4 categories of conditional statements. Okay, although there are more than 4 available, but in your curriculum there is 4 only. Okay, so the very first one is simple if. Next is if else. After that, if else, and the last is nested if. So without wasting time, allow me to show you the practical implementation of all these things, that is conditional statements. Side by side, you will be able to see how to implement logical operators. Okay, so here we go. Okay. So to see the demonstration of logical operators, you can see now. Okay, focus on the screen of our studio. Okay, is the screen is visible to everyone? Yes, yes or no? Okay, either none of the sorry, we can't zoom the screen. Okay, we can't zoom it actually. Okay, either none of the student will say anything, or there is a line of yes or no. Okay, fine. So here we go with the practical implementation of logical operators. Okay, so as you can see that I am assigning this 5 value to x. Clear? If I execute this, okay, in the console screen you can see that. Okay, now I want to print a line. I want to print the output. Okay. In that print statement, I had written is dot numeric x. Okay. Now, what is that? Numeric, as you can see, is the name of the function. And I am trying to figure out that whether x is a numeric type of value or not. As you know, numeric means decimal type of value or floating type of value. So here by writing this is dot numeric x, this means that I want to test, I want to check that whether x is having numeric type of value or not. Clear? I had used a logical operator, that is AND. Okay, this is logical AND operator. Now I want to again check one more condition. Logical AND operator says that if both the conditions are true, only then I will give you output true, else it will be false. Okay, the output will be false. So if the value of x is numeric, if it is true, after that it will again check that if x is greater than 5, 5 is greater than 5, no. Now, this pipe symbol is known as logical OR operator. Okay. Or x is equal to 5. Now, when we talk about this, okay, allow me to just divide it into number of steps. Okay. The very first thing is numeric x. This means that I'm checking what is the value of x, what type of value x is containing. Now, this must be true. Logical and if you see, these both are single another condition. Okay, where for this single condition, see, this is condition 1 and after logical and this complete is condition 2. Clear? Now, in condition 2, again we have 2 sub-conditions. Are you getting my point? Logical operators always work with at least 2 input. Clear? At a time, they can calculate only 2 input only. So, condition 1 is dot numeric x. Second condition is this. Clear? Now, in second condition, we again have 2 conditions. Okay, so here we had put logical OR to identify that either either the value of x is greater than 5 or the value of x is equal to 5. Okay. Either the value of x is greater than 5 or x is having value which is equal to 5. If any of this condition becomes true, this means the output of condition 2 is true and the output of condition 1 is also true, because 5 is a numeric type of value, because to specify the integer type of value, we use capital L. Okay. So if I execute this, what will I get? Have a look on it. I will get true. Just look at the console screen. Let me check what students are querying. Okay. Okay. So, one more. Okay. So, to implement the concept of logical operators, we require two conditions. Okay. Now, let me tell you a simple funda of that. Condition 1, logical operator, and condition 2. Okay. And these conditions will always be kept in parentheses. Keep this in mind. Not only functions are having parentheses, but conditions are also having parentheses. Okay. So what I have written is the syntax. Clear? That how to put conditions. So condition 1, logical operator, condition 2. Clear? Now our condition 1 is dot numeric x. Either the output will be, see, is the value of x is numeric, either you will say yes or you will say no, right? So for that yes, it is true, and for no, it is false. Clear? So our whatever be the output of condition 1 is based on the logical operator. Condition 2 will also be based on logical operator. The output of both of the conditions will be measured to get the final output, which will either be true or false. Like, for example, remember that age greater than equal to 18 example. Now, okay, just focus on this. If age is greater than equal to 18 and nationality is equal to Indian, then you want either eligible or not eligible. But how can you identify that? If I put logical and or single and, what does that mean? This means that the output of both the conditions, that is condition 1 and condition 2, the output for both the condition must be true. Only then the final true will be printed. Clear? If I put, now this means that the driving license or voter ID or PAN card or Aadhaar card will be available to only those people whose age is greater than 18, as well as they are the residential of India. Clear? Now, how about if I put or, logical or? What does logical or do? Okay, logical or means that if any of the condition is true, I will give you true, else it will be false. Any of the one condition, okay? Now, if your age is greater than equal to 18 and your nationality is Indian, you are eligible. Clear? If your age is less than 18, but your nationality is Indian, still you are eligible. This is what logical operator or is doing. Listen to me again. In logical and the output of both the conditions must be true. Fine. But in case of logical or, if any of the condition is true, true will be given. Clear? Now, the thing is, focus on the test cases I'm going to share with you for this logical or. If your age is less than 18, but your nationality is Indian, you are eligible. Why? Because we had used logical or. Second test case. If your age is greater than equal to 18, your nationality is not Indian. Still, you are eligible for, okay, you are eligible for Aadhaar card, PAN card, whatever it is. Okay. Why? Because logical or states that if any of the single condition is true, I will give you true. In the first test case, condition 1 was false, but condition 2 was true. This is why it gave us true. For second test case, the condition 1 was true, but condition 2 was false. So either of the condition is true, I will give you true. This is what logical or says. Next, if your age is less than equal to 18, so assume that your age is less than 18, suppose it is 15, and your nationality is also not Indian, only then now you are not eligible. Are you getting my point? Yes, equal to is for assignment and double equal to is for comparison. Okay. Clear? So this is how logical operator works with more than one condition. That is, at a time, only two conditions can be met, can be written. Clear? Now, okay. Okay. See, logical and states that I want both of the conditions true only then I will give you true. Okay. Else, if any of the condition is true, even a single condition is true, I will give you true. Who says that? Logical or. Clear? Unless and until you do practical at your own side, there will be little bit confusion remains always there. So it is my humble request to everyone that you have to do practical implementation of all these concepts. And this is why I'm also showing you the practical implementation of the concepts. Okay. Now, coming to the conditional statements. The very first conditional statement is simple if. Okay. Now, how to write? What is the syntax to write the if? For example, x is having a value of 39. Okay. Now, I want to check that whether any digit, whether the value of x is positive, negative, or 0. Okay. But because we are talking about simple if means that we can say either the number is positive only. That's it. There is nothing like or. Clear? To check if x is greater than 0, because positive, see, 0 is 0. If we, from 0, if we go to right hand side, all are positive number. And if we go from 0 to the left hand side, all numbers are negative number on the scale, mathematically. Okay. So I want to check that if x, the value of x is positive. Clear? I had not said or not. Clear? So to check that, we need to use if. And by writing if, you have to use parenthesis where you will write your condition. Now here if is not the function. Okay, like print function. Print is a function, numeric is a function. Here if is not a function. As you can see that there is a change of color in if and print. Clear? Although both are using parenthesis. So if is none but the keyword. Clear? So to write the condition, you have to use keyword if, and following if, you have to write mention your condition, and after that you have to print whatever you want to print. Now, before printing something, you have to use these curly braces. These curly braces are what? These curly braces are known as the scope. That is, whatever you write in these curly braces, it will be printed for if this condition is satisfied, that thing will be executed. Whatever logic you write in this curly braces. And this is why these curly braces are known as scope. Clear? So scope is a must, of course. Okay. So if the value of x is greater than 0, output will be printed. The number is positive. Because 39 is greater than 0, the output will be number is positive. I'm just implementing it multiple lines at a time. So the output has been given, number is positive. How about if I put a negative symbol in before 39? Now, if I write this, what will happen? It will give me nothing. Why? Because I had not quoted any logic for that. If the condition is met, only then the output will be print like the number is positive. But if the condition is not met, that is here while writing minus 39 is greater than 0. No. Did we had written anything for the machine? No. Clear? Now, what to do if this condition is false? So, if always carries the true statements. If this condition is true, if 39 is greater than 0, true statement. The true statement is number is positive. But what about if I want to write the false statement that if 39 is not greater than 0, then what to write? Clear? So, next form of conditional statement if is if else. Else will allow you to write the false part. If allows you to write true part, else will allow you to write the false part. Now, age is 55. I had assigned this value to age variable. If age is greater than 18, you are eligible to vote. Else, you cannot vote. Okay. If the condition is met, this true part will be executed. If the condition is false, this else part will be executed. So because I had a value of age 55, now 55 is greater than 18. If you execute this, let us see. You are eligible to vote. Why? Because 55 is greater than 18. Clear? But if I write only 5, okay, again condition will be checked that if 5 is greater than 18, false. In case of false, what will execute? This else part will be executed. Clear? So if I execute this, the message will be appeared like you cannot vote. Are you clear? Any doubt regarding if and if else? See, if you want to give message to your user regarding the truth statement of your condition as well as regarding the false statement of your condition, then you have to write if else both. And if you want to write only truth part of any condition, you can use simple if. Clear? Next is if else. Okay. Now, how to write it? Now, for example, if I want to compare which one is the greatest number among the 3 variables. For that type, I need to use the concept of if else. Clear? As you know, that condition will be written with if statement only. Second point, if the condition is met, true part will be mentioned with if. And if that condition is false, the false part will be executed or the logic will be written in the else. Clear? But how about if there are more than one condition? Either you can use nested if, okay, if within if, or you can use conditional operator that we had learned earlier, like logical operator, that is logical and or. Clear? Okay. So here again we are trying to identify. Look at the logic. x tends to 0, the value of x is 0. Now, here I am checking that if x is greater than 0, print x is positive. Else, if x is less than 0, print x is a negative number. Else, neither x is greater than 0 nor it is smaller than 0. This means that the value of x is 0. This is what written in else. See, whenever you want to write the condition, you have to write it with if only. If you want to write again condition with else statement, then you have to put if again, else if. Clear? Because without writing if, you cannot write the condition. Okay? So if I execute this, what will be the output? Based on the logic, it will give me x is 0. Okay, there is an error. Hold on. What is that error? Unexpected curly bracket. Where it is? Okay. In else if. Did you see that the error has been removed? Here is a problem in this code. The problem was with the indentation. Indentation means what? Okay, look on the screen. I'm going to show you the indentation part. Hold on. Okay. If condition 1, print true part. Okay. Now, after if, it's else. Again, this print false part. Okay. Now, this is getting me an error. Why? Because there is a indentation problem. Just by pressing a tab key or just by pressing indentation means what? This is what the indentation is. Everything must not be aligned with the same line. Clear? You need to write your program with a proper indentation actually. Clear? Now the thing is there is an error because true part and false part, there is nothing like true part or false part. I had just showed you the syntax. Okay. And this is why it is giving you guys error. So I had just made it comment using hash. So to write any of the if else, what you have to do, you have to give proper indentation. Indentation means that if condition, start the curly bracket, then you have to press the tab. After tab, you can close the scope. Again, to write the else, you have to press the tab key and so on. This is what spacing. Clear? Okay, let me check the chat. Okay. See, if you are attending the sessions, intermediary or based on your interest, it is not worth it. Because on day 1 of the practical implementation, I had told you that what is arrow operator and what is equal to operator. In fact, today also I had told you that these two are the same and we use it for assignment of values to any of the variable. Okay, just by asking same repetitive question which are related to the previous session, please, I request you all to come into the lecture only when you had seen the remaining past session recordings. Okay, because you are just asking me wrong question in the wrong session. It is just a humble request because by asking such questions, there is a wastage of time for both of us because the curriculum is so vast and we don't have enough time. Okay, so it is just a humble request. Okay, we were talking about indentation. Indentation means what? Indentation means that whenever you are putting something for something, like to print this thing, to print the true part, you have to use scope followed by the tab key. Okay, and proper indentation will allow you to avoid confusion in your program, as well as your program will look sophisticated by giving proper indication indentation. Clear? So coming back to the if else, there was just an indentation problem. Okay, again it is giving me the same thing. What it needs to do is unexpected token else. Just hold on. Okay, what happened? Fine. Okay, can you see the codes? There are tabs provided by me. This is what the indentation is. Okay. Now, if I execute with this again, okay. Okay, fine. Now the output has been printed that a value of x is 0. So this is what proper indentation is required even in R as well as Python. Okay. Yes, elif can be used, but right now because you are on very beginning age, let's not make it very complicated. Okay. So this is what indentation looks like. As you can see that after if, while opening the scope, I had just pressed tab key and just written the print statement, then close it, followed by the else part, which is again containing the false statement for this condition. But because there was one more condition I need to check, so with else I had to write if again, because condition can be written by if only. Okay. Again, this print statement is the truth part of this if, and the false part of for this condition is over here else. Okay. So this else is having its own if else. If you see, Python strictly follows the indentation, but R do follow indentation. And you can see few seconds ago, there was a problem with the indentation only. Okay. Although Python is very strict type with indentation, although R is flexible with in terms of indentation, but it requires indentation to some extent. Okay. So this is why it was giving us error earlier. So to avoid those errors, see, there is this logic is not that much complicated. Okay. But the fact is, if still you are getting the error, this means that there is a problem with the indentation only. Okay. So by using if else, what we are trying to do is we had just put a logic to identify that whether x is positive number or x is negative number or the value of x is 0. Okay. Now, the thing is, how many total number of conditions we have? We have total we have total two conditions. Either the x will be greater than 0 or it will be less than 0. And if both conditions are not met, then this means that the value of x is 0. This is what we have done over here in this logic by using if else if else. Clear? Any doubt regarding this indentation? Regarding this logic? Okay. So whenever you want to provide truth part of the condition as well as false part of the condition, and there is not only single condition, there are more than one condition. So for that you have to use ladder. This is ladder if else. Clear? Technically it is known as ladder if else. Now the next is nested if. Nested if means if within if any condition, if any if statement is containing itself a if. Okay. This means that it is nested if. If you see the previous code, here it was if condition 1, then else, that is the false part of this condition. But again, I want to put a condition. So this else was followed by again if condition, which was the different condition 2. This was condition 1, this is condition 2, but this condition 2 will be checked as the false part of condition 1. Clear? And this else is the false part of this if condition. So based on your requirement, you have to identify that where you want to put the condition, whether it is nested if or ladder if else. Clear? Now, coming to the nested if. Here, again, we apart from identifying a positive or negative number, we are also trying to figure out that that number is even positive or odd positive. Even positive means greater than 0, as well as that number will be the multiple of 2. This means even positive. And if that number is not the multiple of 2 and stands on the right hand side of the 0, this means that it is odd positive. Clear? So logic goes like that. X tends to minus 20, which means negative value has been assigned to x. Clear? To check whether the number is positive, again we have to write if x is greater than 0, fine, which is not matching over here. So let me remove the subtraction to get you guys concept easily. X tends to 20, which is a positive number, fine. If 20 is greater than 0, condition is true. What will happen? The truth part will be, see, this and this. Indentation is provided. Clear? So, if 20 is greater than 0, now we will check that whether that number is even or odd. And the concept of even and odd can be identified based on the modulus arithmetic operator. Clear? Modulus arithmetic operator works with the remainder. Okay, as an output, it will give you remainder. For example, if you are about to divide 5 by 2, okay, 5 divided by 2 will gives you the quotient as output. That is 2 will be the output. Clear? And what is remainder in that? remainder is 1. So to get that remainder 1, rather than using divide operator, you have to use modulus operator, because modular operator will divide, but the output generated will be given by remainder only. Clear? So if you want to check that whether a number is positive or not, so the very first thing is, first condition, 20 is greater than 0, true. Second, if x modulus 2 is equal to 0, this means that x is a positive even number, okay? And if x modulus 2 is not equal to 0, this means that completely, either if the number is completely divisible by 2, then the remainder will be 0. And if remainder is not 0, except 0, any number is remain, this means that that number is odd number. Clear? So for this condition, next false condition is x is a positive odd number. Because x is a positive number, we all know in using this condition 1. But again, we had applied condition 2, which will calculate whether the number is even or odd. And based on that condition, the output will be generated. Now, the fact is, what will we do if the number is not positive? Suppose it is a negative number. Let's say if it is minus 20. Okay, first of all, let us execute this, so that you will get the complete idea. Okay. X is a positive even number. Why positive even number? Because 20, for 20 value, okay? 20 is greater than 0, true? And 20 divided by 2 will give us 0, complete 0, remainder, okay? So this is why it has been written that X is a positive even number. Clear? How about 21? Again, 21 is greater than 0. It is a positive number, but this time output will be x is a positive odd number. Okay, let me show you back the execution. Okay, x is a positive odd number. Clear? Now, how about if x is not a positive number? That is, now I'm going to write negative value, minus 21. Minus 21 is greater than 0? No. Where does the interpreter will go? Interpreter will go with the else part. Okay. Again, it will check that whether that number which is negative, now it is not positive at all, it is negative number, whether that negative number is even or odd. Clear? So based on that, minus 21 is again negative odd number. So it will be displayed as output that x is a negative odd number. So let me show you the implementation of this for value of x as minus 21. So x is a negative odd number. How about if I put the value 20, that is minus 20. Now you will get x is negative even number. Okay, so this is how multiple conditions we had introduced in this logic to see the demonstration of nested if. Where was nested if? See, the nested if is over here. This is if condition. First condition, if within if. This is the point of, this is the concept of nested if. Nested if means if within if. Clear? Even this concept is also using the concept of ladder if else. If you see, if, else, again if. So if, else, if is the concept of ladder if else. Clear? So this program is demonstrating you the utility of how to use nested if concept as well as ladder if else. Clear? If you have any doubt regarding this logic, regarding this implementation, you can ask. So, shall we move forward for the next concept? Okay. So till now you had see what is simple if. If you want to execute only and only true part, you can use if, provide condition, and just write in the scope, just write truth part. Clear? If you want to give along with truth part, you want to also execute or display a message for the false part, you can use if else. Where with if you will write condition and the truth part, and with else you can write the false part for that condition. If else, what will it do? It is again, if you are having more than one condition, okay, condition one will be written with if, and for that condition's false part, on getting that condition false, again you want to apply a new condition. Okay, so for that, you have to write, okay, let me take the pen. For that, you have to write if with the else part. Okay, this pen is not visible. Hold on. Yellow. Okay. Condition one will be written over here with this if. Okay. Now, if what about the false part of this condition one? That false part will be written along with else part. Now, rather than having the exact false part, I have some another condition to write to check. So with else, you have to write again if. And this else part will be for this if condition. Clear? So this is how ladder if else works. And the last is nested if. Nested if means if within if. Clear? If an if condition is followed by the next if condition, this means nested if. Clear? Now, again, a major topic in R, that is loop. Loops in R. What are loops? See, loops are used to repeat something. Okay. But the fact is, okay, let us take an example. The fan will rotate continuously. If you switch on it, the fan will rotate continuously. When the fan will when the fan will stop rotating, there is again condition. If you want to if you want to stop that repetitive activity of fan to rotate, if you want to stop this rotation, what you need to do? You have to put a condition. Clear? So again, one conditions you had seen in conditional statements like if else, if else, if else, and last was nested if. Next is you will see conditions in loops also, because loops provide you iterations, loops provide you repetition. To stop that repetition, again you have to impose a condition. Clear? You have to write a condition to stop that thing. Okay. Likewise, to stop the rotation of fan, you have to switch off. This is the condition. If you switch off, fan will stop to rotate. So this is what even in loops you have to mention. Clear? In R, we have 3 loops: for, while, and repeat. Okay. Any doubt regarding conditional statements, you can ask, because now we are going to deal with loops. Okay. Shall we continue with loops in R? And this makes this means that you are not having any doubt. Okay. Okay, fine. Thank you. So, what are loops? For iteration, for repetition, you require loop. Okay. For example, what is the example of repetition? For example, I want to design a code where I would like to print mark sheet for a class whose strength is 100. For each of the 100 student, I have to write it, his or her roll number, his or her name, that is enrollment number, okay? His or her enrollment number, his or her name, class, section will be the common thing, marks for each of the five, let's say five subjects are there. So marks of five subjects, then based on those marks, I have to calculate total. Based on total, I have to calculate percentage. Based on percentage, I have to mention grade. Clear? So all these stuff is a repetitive. For student 1, I have to do it. For student 2, I have to do all these things. For student 3, 4, up to 100. For 100 students, I have to do it. So this is how I have to write the code. For example, if student 1, if I'm writing specifically, let's say that total number of lines for doing all this activity, total number of expected line will be around 30. Okay. So for each of the student, I have to write those 30 lines every time. Okay. So for 100, it will become 300 lines. And by doing this, I will require multiple variables for that also. So more variable, this means more memory will be occupied. This means system will get hang. This means system might get crash. But this is about a class only. But if we talk about university, university is having thousands of students. Is it feasible to write those 30 lines for thousands of students? Let's say that university is having only 1,000 students. Is it worth it to write those 30 lines for 1,000 of students? It is not worth it. What you will do? You will write once and repeat it every time. Clear? So there is where loops concept comes into the picture. Hold on. Okay. So in R, we have three types of